Let's consider a question here. Now question given is the open loop transfer function of a system. The open loop transfer function of the system is k into s plus 2 divided with s square 2s plus 2. We have to draw the root locus of above system We have to draw root locus of above system. Now see the solution. How we draw the root locus of this type of system. First we have to calculate what is the open loop. We know roots are always started from open loop poles and terminated at open loop 0. So first we calculate where is the open loop poles are. Now from equation C, open loop poles are this. When we solve this equation, means if we solve s square 2s plus 2 equal to 0, then you can get what is the roots of this equation. And the roots of this equation are -1 plus 1j and -1 These are the roots of this equation. Means s1 is equal to -1, sorry, this is the -1 plus 1j, and s2 is equal to -1 This is the roots of this equation. I have written here, right? Just make it erase here. No need to this is nothing, means these are the roots of this equation. If you making s square 2s plus 2 is equal to 0, then we get the roots. Now what is the zeros? Of this system? Where is zeros of this? There is only one there, so we can write there is the 0 is at s is equal to -2. Then what to do? First locate these poles and 0 in complex plane, or if there is a complex plane, means that is a sigma plus j omega, that is the s plane here, that is the sigma here, that is omega here. Now what is the, I am saying that what is the poles? The poles are nearly, this is a -1, this is the location of poles, these are the location of poles, and 0 is located as equal to -2, means something here 0 is located s is equal to -2 located here. This s is equal to, this is the 0 and these are the poles of the system, open loop system. Now first we check where the root locus are exist on real axis or not, right? Now when I am standing here, then I see, when I am standing here like this, then I have seen right side. In right side there are even number of poles, means root locus cannot exist below this point. Means root locus cannot exist in this region. Means the root locus cannot exist in this region. Clear? Now move some step in left and stay here. Now see again in your left, in your right side, a number of poles in there. We know that a number of poles in 0 in right side, 1 2 3. 3 is the odd number, means root locus exists in this region, means left side of -2. Root locus cannot exist in this region, means these are the region of root locus. Clear? Means these are the region of root locus. I say these are the region of root locus, or root locus cannot exist in this region. Now calculate. What happened? We know the root locus always started from the pole and goes like this and come to terminate here. Again always started from pole and goes like this, terminated this point. Now this is the first of all, when root locus start moving like this, then what is the direction of roots from here? What is the direction of roots from here? Clear? What is the direction of roots from here? Second one thing is, now first we find the direction of the roots from here, means what is the angle of departure from here. Clear? What is since it is the poles, then we have to calculate angle of departure here. Now what is the angle of departure? Angle of departure is calculated here. Angle of departure denoted normally phi t, or we know that angle of departure 180 degree plus phi z minus phi p. This is the angle of departure. This is the angle of departure. I am calculating angle of departure at minus 1 plus j. This is the pole minus 1 plus j. This is the pole minus 1 plus j. Or this is the pole minus 1 minus j. Or this is the pole at s is equal to 0 at s is equal to minus 2. Now what is the angle of departure at this pole? What is the angle of departure? Now see how I am calculating. See here. First we just take a pencil and take a pencil and draw a line from there to here, like this, and draw a line here. Okay, and draw a perpendicular line and find that this is what is the phi z. Angle subtended by 0 means there is only 0. What is this angle? What is this angle? This is the phi z. What is this angle? Phi z means what is this? If I draw a perpendicular line, this become minus 1, and the base is 1 and height is 1, right? Height is 1. So we can say phi z is tan inverse 1 divided with 1 minus. Clear? Phi z is tan inverse 1 divided with 1, and just erase this here. Just erase this because it disturbs our focus here. Clear? I have calculated phi z. What is the phi p? Phi p is nothing but again take a pencil here and just after doing some practice on this question, we can easily calculate without drawing this line. What is the phi p? Phi p is this is the 90 degree. Phi p is angle subtended by other poles, or this is the 90 degree. Means this is the phi p is 90 degree pi by 2. This is the pi by 2. Yeah, at 90 degree. I say this is the 90 degree. Now make some calculation here. This is the 180. This is the 180 here. 180 degree. This is the 180 degree plus what is tan inverse 1 by 1? 45 degree minus 90 degree means 180. This become minus 45 means 180 minus 45 means 135 degree. 135 degree. That means at this point angle of departure is 135 degree. Again draw a line here like this, and 135. What is the angle of 135? This is the angle of 135. Clear? This is the angle of 135 here. 135 degree. Clear? Now similarly we have to find what is the angle of departure at this pole. And now see here, these poles are complex conjugate, so angle of departure at this pole is just opposite to this one. This is plus 135, so angle of departure phi z, so angle of departure phi d, sorry, this is the d, phi d at angle at minus 1 minus j is minus 135 degree. Clear? Because these two poles are complex conjugate, no need to calculate the angle of departure here. The angle of departure here is just opposite to the angle of departure at this point. Means we have to draw minus 35 degree here. Let's take here line or take a pencil and draw minus 35. In this direction there is the plus 135, and in this direction this is the minus 135. We draw line here, means minus 135. This is the angle minus 135. I am going to erase this point here. This is the angle minus 135 degree. Clear? Means from here poles are started like this, right? Okay. And this pole are started like this. Means from 180. I am using something blue. These poles are started like this, and it come to here. clear? This pole will start like this and come to this point here. This is the angle of departure. We have calculated the direction. Similarly, this from the root locus started from this pole and goes to here and something here. This line is not exactly curve. I try to draw a curve here. This pole is started and goes to, something like this. This is making a perfect curve here, right? This is making a perfect curve here, not like this. This is perfect curve here. Now this is poles goes like this here. Okay. Now this is the poles. This is the perfect curve here, not like this. This is a perfect curve here. Then what happened? This is now see here. Now. That means completed part. This is the theta 135 degree minus 135. This is the angle of departure at -1. This pole is known as now this pole is -1 minus j. These are the polar. Here we have already calculated here. Okay. Now draw this line something more. Now see here, the poles, the root locus are coming from complex plane to the real axis. If the root locus coming from complex plane to the real axis, then this point is known as break-in point. We know the definition of break-in point. The definition of break-in point is if the root locus is coming from complex plane to the real axis. Means if the root locus is coming from complex plane to the real axis, then that point is known as the break-in point. Means this is the break-in point. Remember that part here. And we also know that the value of k at this point is the value of k. Now we already know this part. Now that value of k at pole is 0. We know this. Value of k is pole is 0 again here 0, and value of k at 0 is infinity. What is the k? Is the nothing but this again of the system. This again of the system. Now see here, this is the break-in point. Why it is a break-in point? Since the poles, since the root locus is coming from complex plane to the real axis, so it is a break-in point. Here this root locus break into the two parts. One part may goes in this direction, and second part may goes in this second part, that is the blue line, that goes in this direction and terminated at 0. So now see here, number of poles in this open up transform. So number of poles p is 2, number of 0 is 0. Means number of asymptotes are 2 minus 0, that is the 2, and there is number of 0 is 1. So 2 minus 1, there is the 1. Means there is one branch of root locus going to the infinity. Means this branch of root locus going to the infinity, at where we assume that there is the imaginary 0. And this root locus goes and terminated at that point, and at this point value of k is infinity. This is the imaginary point. We assume that there is the 0 on the infinity. This is the number of asymptotes, right? This goes and terminate here. Now we have to calculate what is the value of this break-in point. What is the value of this break-in point? This is our task. How we calculate the value of break-in point? To calculate the value of break-in point, now we follow some process. that is the we know already. To first we write the 1 plus characteristic equation of the system. 1 plus GSS is equal to 0. Now put the value of GSS as k into s plus 2 divided with s square to s plus 2 is equal to 0. Now what is the value of k? We can write this is the s square 2s plus 2 divided with s plus 2. This is the value of k. Now differentiate this equation, differentiate this part, take this one again, differentiate del k over del k with respect to the s. There is the some value, we get some value here, and differentiate this point and we get some value at this point. Means okay. Differentiate this and we get some value at the point. Now I'm getting something different. Okay. Now what is the after differentiation? What is the differentiation of this s plus 2 whole square? Differentiation, this is a minus, take minus outside of this bracket, numerator, this is the numerator part, 2s plus 2, this is the 1 plus 0 minus. Now solve it. This become s square, this become 2s plus 2 plus 0 into s plus 2. Now solve this part of this is the differentiation of this equation. I'll make del k over del s is equal to 0. Now when we make del k over del s, then this term goes to 0 and this minus sign also goes to 0, means I have content and there is only this quantity remaining. This multiply with 1 and this when we are going to multiply with this quantity minus 2s plus 2 into s plus 2 is equal to 0. Now calculate again, that is the s square 2s plus 2. What is this value? This is the 2s square or this is the 4s or 2s, this is the 6s and this is the 4 is equal to 0. Again solve here. I am going to solve here this equation, that is a minus s square minus this is minus 6s or plus 2s minus 4s, this become minus 4 plus 2, this is minus 2 is equal to 0. Hence s square 4s plus 2 is equal to 0. S square 4s plus 2 is equal to 0. That become, if we solve this equation, then we get s is equal to minus 2. And then we get s is equal to minus 2. Minus 2 and minus 2. There is something error here. And we can't get s is equal to minus 2 here. This is not a solution. First to solve this equation, use a calci. I am using a calci to solve this type of equation here. Value of a is 1, 4, 2. This become the solution of this equation is s1 is equal to minus 0.5 and s2 is, if I say s1 s2 are roots, then s2 is minus 3.4. These are the roots of this equation. Means let's say where is this point s1 0, where is 0.5, where is 0.5 located at this point, but root locus are not there, means 0.5 is the invalid point. This is the invalid point, and but minus 3.4 are something, this is minus 2 something, this is the minus 3.4, means 3.4 is the valid point, means 3.4 is the valid point. This is the valid point on the root locus. Means we have calculated here, means value of s as the break-in point is value of s at breaking point is minus 3.4. This is the value of s at breaking point. Maybe someone asked that what is the value of k at this point. When we increase the k1, k is equal to 0, we are staying here. K is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we increase the k at infinity, we goes here and here, right? But there is some finite value of k for which roots are coming at this point, means roots are located at this point. We have to calculate what is the value of k here. Now this is a very easy task. We use the magnitude criteria. We know that any point S1 lies on root locus if and only if it satisfies, this is S1, if and only if satisfy the magnitude criteria and angle criteria here. But here I am using the magnitude criteria. Means if I have a transfer function is ks into s plus 2 divided with s square 2s plus 2. If we put s is equal to minus 2, s is not minus 2, this is what is the point, s is equal to minus 3.4, s is equal to minus 3.4, and make it 0, then whatever value you are getting, that is the value at this point, that is the value of k at this point. Now solve this. This is the magnitude criteria. This is known as the magnitude criteria. Now let us solve this problem. Now k, this is the minus 3.4 plus 2 divided with minus 3.4 square, like this become minus 3.4 square plus 2 into minus 3.4 plus 2. Okay. This is the modulus value here. Modulus value of this become 1. Now solve it that point later once again. Now okay, solve it. This become k, or this become minus 1.4. This is square of 3.4. Square of 3.4 is 3.4 square 11.56. Clear? Minus 3.4 multiply with 2, minus 3.4 multiply with 2, 3.4 multiply with 2, that becomes 6.8 plus 2. Modulus, take the modulus value of this is the. Now again find the value. This become 11 point. Where is the? This is the 11.56 minus 6.8 plus 2, 6.76, means this will become 1.4 divided with 6.76 modulus value, or this is the one. Now solve again, or we get k is equal to 6.76 divided with 1.4. 6.76 divided with 1.4 means 4 point. This is the value of k is 4.8, right? 4.82, right? 4.82 means if the at this point value of k is means at breaking point value of k is 4.82. Means if we put the 4.82 in this equation, then we get a system which if you put the value k is equal to 4.82 in this system, then we find our roots are equal and they are crossing at penalty चैन वाला है. हम क्या करते हैं, हम यहाँ पे देखने वाला है कि अगर मैं इस ट्रांसफर फंक्शन को मैटलैब पे राइट करूँ, मैटलैब एक सॉफ्टवेयर है, उस पर अगर मैं इसको प्रोग्राम में राइट करूँ तो क्या मेरा रूट लोकस कैसा मिलेगा. नाउ से हियर if I have a MATLAB, this is the I have written this program here. There's a CLC clear. This is the our transfer function s plus 2 into s square plus 2s plus 2. This is our transfer function. Or I am using the command r locus. Means this is the root locus. Just remove the semicolon here. I want to see the transfer function in denominator. on the command window. Now see our transfer function. This is our transfer function, or this is our this is our transfer function. See, this is our program. This is our transfer function, which is already given. I am using here for designing purpose. We using here k is equal to 1 because it is necessary to define each and every variable here. So now see here. This is the final root locus of our program. This is the final root locus of our design. Now I am going to minimize here something little bit here to adjust the window. Now this is not a requirement. Now see here, this is the output locus, and our design we have designed here. This is our design, or this is the output from MATLAB. Now see here, we are going to compare here. We are going to compare what is the design and what is the output I am getting here. Clear? This is we designed this by help of some formulas and some process, some mathematical calculation. But the same transfer function when I am put in our MATLAB program, the same transfer function where I am putting in our MATLAB program, then output is look like this. Now see the comparison between these two. Now see here, just to delete here in this part. I need to delete 1 second. Now see here, when this is the cross point, right? This is the cross means pole, means this is the pole exactly equivalent to this one which I have designed here, right? This is the pole here, and this is the 0. Now when I am clicking here, like after clicking here, the poles are -2. This is poles are -2, or this is the circle here. This is the circle here, means it represents the 0. It represents the 0. Clear? Now at this point, gain of the system. See the gain. This quantity. See this quantity very important quantity here. See the gain of the system is INF. INF means infinity. Means we have already written that gain of the system at pole is infinity. Clear? And this is the 0. At 0 is infinity. Here it is writing it is a pole. It is not a pole. It is a 0. But this is the symbol here. And the symbol is something different like this, right? Okay. It is clear, everyone. Now see, when I am clicking here, then I am getting our pole is -1 plus 0. Nearly this is equal to -1 plus 1j. This is something when I am moving like this and this, then value of pole is also changing. Clear? Or here the gain of the system is 0.067, means nearly equal to the 0. If I am getting exact -1 and something is moving again, and this. Now see, when pole value of the pole is -1 plus 1j, the system gain is now see the system gain is 0.00286, means system gain is very less. Clear? Or this is equivalent to k is equal to 0. Now when we increase the value of k, now see here system gain is something 0.7. when you start moving like this, see the gain of the system is increasing. Now see here, the gain of the system is increasing, and poles are also changed, and damping ratio of the system is also changing. Now see here, the gain of the system is increasing, and move like this and moving and move like this, and goes at this point. Now what happened at this point? The system, what happened at this point? The gain of the system is 4.83, or by calculation we get our gain of the system is 4.82. Now by calculation we are getting our gain of the system is 4.82, but MATLAB said that the gain of the system at this point, means a breaking point, is 4.83. And what is the location of breaking point? This is location of breaking point is -3.41, means just or this is e to the power -8. That is a very less quantity. Don't think about this. Means this is the pole, and we are getting the same pole nearly here. Now what happens if our gain is increasing means gain means value of k is increasing when we are moving from here to here. Again if I am moving, if I just did a right click here and delete this, if from here when I am start moving increasing the value of k, when I am increasing the value of k like this, then what happens, see here, when I am increasing the value of k is increasing, see this quantity here, the value of k is increasing and goes the value of, means I am in our system I am increasing the value of k, right? When I am increasing the value of k, the k goes like this, and at this it is at this point, but at this point both the pole are equal, right, and gain is equal. After that what happened, this pole, the pole is split it into two parts. One part goes in this direction, second part goes in this direction. When the pole goes to this direction, see again k, value of k is increasing here. When we moving like this, value of poles are gain of the system like this, value of gain is increasing goes like something. When we move in this direction, now see we can't move this quantity in this direction, this pole now see this pole is coming from here and goes like this. If I am dragging in this direction, it cannot move in this direction, like it cannot move in this direction, means this pole is moving only in this direction. And similarly this pole, we can't move this pole in this direction like this, like see, when we can't move this pole in this direction, this is not possible for me. And when we moving this pole, now see here what happened there. So when I am increasing the value of k is here 4.8, again increase and goes to 5.51. Then what happened if I am here, here again system, now see at these two location gain of the system is same, as two location gain of the system is same, but the poles via roots of the system are different, This is the very important part here, means if the root gain are same but roots of the system are, poles of the system are different, means that system is, poles are real and unequal, or that system is overdamped. This system is overdamped system. And when at this point poles of both green and blue both are same, means when roots are equal, then system is critical damp. And when we move in this direction, we can't move this in this direction because it's coming from here. When you move in this direction, then see here the gain are maybe equal, but see the poles, about the poles 4.01 make the gain 4.01, make the gain 4.01, sorry, here 4.01 is the gain, 4.8, here 4.0, now something like this. When we are moving, now see here in this area the poles are in complex in nature, but at this point the poles are in real in nature. When poles are complex in nature, then this is the underdamped system. Now see here the damping ratio is 0.9, right? 0.9 means less than 1, greater than 0, right? Now see here the damping ratio is 1. Here damping ratio is 1. When you're moving in this system, the damping ratio system is 1. Clear? Okay. Now we see here the poles are equal and this goes like this, means our design our design, this is the design I have designed by using some mathematical calculation and some other process which already discussed in lecture 1. And when I am going to design this same equation in our MATLAB program, the MATLAB program said that okay, this is the locus hour, means this is the replica, something like replica. The in our design this is exactly not current, but this should be look like this. Okay. Thank you very much.